All right, so in this sample problem, we've been given a rather lengthy question, and we're going to need to use an ice table in order to solve it. In a 500 milliliter stainless steel reaction vessel at 900 degrees Celsius, carbon monoxide and water vapor react to form carbon dioxide and hydrogen. This establishes an equilibrium with only partial conversion of reactants to products. Initially, 2 moles of each reactant is placed in the vessel. This reaction's Kc is 4.20 at 900 degrees Celsius. What is each chemical's concentration at equilibrium? So what we see here is we have an equilibrium reaction. It's happening at a very high temperature. And from its Kc value, we know that the products are going to be favored. Now, in order to start this question, we are going to have to start with writing out the chemical reaction. The temperature here doesn't actually change any of the calculations, but it is a good reminder that when we deal with water in this question, we're dealing with water as a gas. And that's going to be important later on because that means that water will be included as a term in our reaction coefficient or in our equilibrium law. So we have carbon monoxide to start with, not dioxide, plus water vapor reacts to form, now we have the carbon dioxide plus hydrogen gas. Okay, so once we've got our equation written out, we can start building up an ice table. I'm going to write out ICE. Remember, this stands for initial change and equilibrium. Now, I'm not going to write out each word every single time. I'm just going to write down the first letter in the acronym. Other thing that I'm going to do is I'm going to split this up into columns. Each one of the columns represents one of the different chemicals involved in this reaction. And I'm just going to move over my words so that we get the full space for the carbon monoxide. There we go. So what I'm going to do is I'm going to start by writing out the concentration of each of these chemicals in the initial row. It is important to remember that the ice is all in moles per liter. What we were initially told was there's 2 moles of each reactant. However, it's in a 500 milliliter stainless steel vessel. So it's 500 milliliters, half a liter. So we need to remember to double up our initial concentrations to 4 moles per liter. I'm going to write moles per liter on this first one, but I'm actually going to just write the number for the rest of them because it gets very cluttered if we don't. Now, what we see as well is that it only talks about the reactants that are present at the beginning. What that is implying then is that the concentration of the other chemicals not mentioned is 0. And most often this will be the type of scenario that we see, where we have a certain amount of reactants present. It may or may not all be the same, and then no products will be present initially. The math is possible if there are products present initially, but it does become much more complex. Now, we don't know what the change is and we don't know what the equilibrium is going to be, but we do know that in this balanced equation, we have a 1 to 1 to 1 to 1 ratio between our 4 chemicals. So the amount that carbon monoxide and water decrease by is going to be equal, and so is the amount that carbon dioxide and hydrogen increase by. And in fact, all four numbers are going to be same, the reactants will just be negative and the products will be positive. So we can represent this with a variable, and as we love when we're doing math, that variable is going to be x. Each of them are going to change by a value of x. However, our reactants will be decreasing because they're the only thing present. They have to decrease, and our products will be increasing, which makes sense. They're being produced. So our equilibrium concentrations, we don't have numbers yet, but we can write them as mathematical terms. For our reactants, they will both, at equilibrium, have a concentration of 4.00 minus x. And then our products will have a concentration of x. This doesn't get us any closer to numbers right away, but it is going to be key to solving for a number. The other thing we need when we're working with an ice table is we are going to need our equilibrium law expression of Kc equals. Remember that Kc is always equal to products over reactants raised to their exponents. Nice thing about this reaction, no coefficients. Everything is equal to 1, so everything's to the power of 1, which makes the math nice and easy. It will be concentration of carbon dioxide times the concentration of hydrogen over the concentration of carbon monoxide times the concentration of water. This is why it was important that water was vaporized and at this high temperature, because if it was liquid water we were dealing with, it would not be included because liquids don't influence Kc. Now, conveniently, we also know what Kc is equal to. 4/20. We also know what each of the equilibrium values is. We don't know exact numbers, but we have mathematical variables we can plug in. So let's do that. We have 4/20 is equal to our products, x times x, over our reactants. Use the right bracket there. 4 minus x times 4 minus x. Of course, we can simplify this a little bit. We can put x squared on top, and we can put 4 minus x all squared on the bottom. Okay, we want to solve this. What might be the instinct, especially if you've been doing Math 30, is, okay, let's turn it into a quadratic equation. We can solve it using the quadratic formula. And you can do that, but that's going to give you two possible answers. Now, one of them will probably be positive, one of them will probably be negative, so it makes it easy to suss out which one is the correct answer. But there's a better way to solve this. We know that 4.20 is equal to x squared over 4 minus x squared. I can just take the square root of both sides. So taking the square root of both sides is going to get rid of those squares that we have on the right-hand side. That's going to turn this then into 2.05 is equal to x over 4 minus x. Much easier to solve than trying to use the quadratic formula. Okay, we're going to bring that 4 minus x over. So we now have 2.05 times 4.0 minus x. We are going to factor that in. That will give us 8.20 minus 2.05x is equal to x. That means we can bring the x over. So we get 3.05x on one side. We get 8.20 on the other side. I can divide both sides by 3.05. X is equal to 2.69. Okay, so if we want to bring that all the way back up to the top here, we now know our x value. So we can solve for the values that we want for our final answer. Just going to move this down a little bit so it's easy to write and see. So our value was 2.69. So for both of these, it will be equal to, don't need the brackets anywhere, no more, 4 minus 2.69. That is going to give us a value of 1.31. And of course, x is just going to be 2.69. And if we think all the way back to our Kc value, this makes sense. We knew that Kc was equal to 4.20. So we expect that the products are going to be more heavily favored than the reactants. The products on this side are more heavily favored. The reactants on this side, less so. So our check at the end of this question comes out all good.